The 4000X family, our flagship family of devices, our first devices we ever did. They're relatively simple devices in that they are matched for broadband performance. They're matched for broadband return loss, noise figure, IP3 and P1, with the fact that you're going to accept gain roll off to simplify the design. And you would think there was nothing special about them. You would think there was nothing special about them. However, it's a shocker, because the 4002, which is kind of like the mid-range of, well, he's smaller than some of the other ones, but the 4002 gets designed in everywhere, okay? The 4001 was a smaller version of the 4002, 5 volts, 40 milliamps versus 5 volts, 70 milliamps. They're all carbon copies of each other. The only difference is size. As you get smaller, you can match them more broadband. As you get larger, more narrowband, but still broadband enough, higher P1s, higher IP3s. So you have 4001, you have 2505 with a shorter down bomb, which enabled higher frequency. But then I found out you could bring it low in frequency, so that the 2505 in my mind effectively replaces the 4001, unless for some reason you want lower gain. 4002 is a step up in size, probably potentially our most popular part. 4003, another step up in size, 5 volts and 95 milliamps versus 70. 4004, 5 volts and 135 milliamps. 4005, 5 volts and 165 milliamps. As you get bigger, you get higher P1 and higher IP3. So that's our broadband 4000X family, and you know, they get used. Gosh, they get used all over the place. You know, when somebody needs we have wireless microphone customers who need a mid-range power amplifier, and they're using 4005 because it has a high enough P1 and for their application, and you know, it has low enough power dissipation too. So depending on the application, the 4000X family, I use them all the time. IP3s, you start out with 2505 or 4001, you have an IP3 of high 20s to very low 30s. 4002, 33, 34 dBm. 4003, 36 dBm. 4004, 38. 4005, 39. If you match it just right, 40. So anywhere from 30 dBm to 40 dBm. And you have the compression point deltas as well. Compression points, 18 dBm for 4001, 2505. Low 21 to 22 dBm for 4002, 23 dBm for 4003, 24 to 25 dBm for 4004, and best case 26 plus dBm for 4005. Noise figures in all of them, sub 1 dB. Sub 1 dB best case. In other instances, higher frequency, and depending on how much matching you put on the input, 1 to 1.5 dB. So it all depends. The smaller the device, the more broadband you can make it. You know, but 4005, I've matched from 136 megahertz to 944 megahertz. So that's a large percentage bandwidth. So they're all broadband. But ultra, super broadband, the smaller ones are what you're going to use. They are super stable. I see no issues, except for the only complaint would be gain roll-off. That's the only complaint. There might be a complaint, but I mean, you can't have everything. You just can't. So the only downside would be gain roll-off. You know, you show them a broadband match for the for the 2505 goes from 100 megahertz to 6 gigahertz. The gain will go from 22 to 11. Okay, so that's considerable gain roll off, but that's a large chunk of frequency. So that's the only drawback that I can see. I don't have problems with them. They're very friendly. No disasters. No disasters. Nothing bad happens. No, they're very trouble-free. Process variation is entirely reasonable and is dictated by our production test limits. You know, your process variation, the only unrecorded process variation would be IP3. We don't test for IP3. We test for P1 and we test for idle current. We test for gain. So you know where that's going to land. You don't test for noise figure. You don't test for IP3, but historically, I don't see problems. I don't see problems. And customers, very demanding customers, satellite radio customers who need certain specs to be at a certain place are not running into problems. So they're pretty solid over process.
Any of you guys call me Francis, and I'll kill you.
Temperature, same thing. And if you want to see the over temperature performance of any device, look on the data sheet. We have it. You'll have some bias variation. Your P1 will degrade hot a little bit, but not bad. It's all there, and it's all within reason. Yep, they sure are. You can drop them in. You can drop them in, and I do it all the time. You know, we had really difficult specs at a public radio company that required me to match the 4005 and some other devices in the family from 136 to 944, and they looked at the trade-offs and they decided which one they were going to use. So the pin-to-pin compatibility helps me, because all I have to do is plop it down on the eval board, maybe change the bias resistor, no matching changes, and run the data to compare them. If a customer runs into a problem, all of a sudden they need more gain, and they have a DFN6 package, which is just about all the little smaller devices, we give them an option that they can drop in. It helps me out all the time. So because it helps my customers out. Turn on and turn off times will be less than 500 nanoseconds. The only thing that they got to keep in mind about the turn on time with any of our devices, if you have a requirement, sometimes the capacitance you hang off the output collector, or if you for some reason they put capacitance on the V-enable pins, that's going to affect that may affect your turn on time. They're very friendly. You can cascade the parts. These devices, 4000X, you can cascade them. What you need to understand is that their gain roll off's gonna get amplified, right? If you have significant gain roll off, you're gonna see that down the line. And I've had customers do that and come to me and say, we need an option. So I oftentimes put in another device in front of it, or we're actually designing devices on purpose, intentionally right now, to have positive gain slope to combat cascaded gain roll off. So we're going to be purposely, I don't know if, as long as you're okay with it, as long as you're aware of it, I believe we intend to design devices that intentionally have positive gain slope going into the future. We just had a customer that I had to go through all kinds of matching gymnastics to get positive gain slope. If you can design positive gain slope inherent to a device, that's big. You could have a whole family. You could have a family of devices with positive gain slope, and customers are going to jump all over it. So that's something we should do. I think we're going to do it.
Thank you so much for watching. If you'd like more information, please email us at sales@gorilla-rf.com. And don't forget to subscribe to our channel for more content from Gorilla RF.